Hi everyone, and welcome to the final solution, which is extension section question 7. So this is the final solution video to the Python worksheet. And in question 7, it says, using the data in table 2, who will experience the greatest gravitational force? Is he an astronaut that has a mass of 95 kg on Venus, or an astronaut that weighs 50 kg on Jupiter? Essentially, what this question is trying to make you think about is the effect of gravity on different planets and how the size of a planet affects the effect of gravity you would experience on it. So in this case, Jupiter is a bigger planet compared to Venus. And if you have a look at table 2, you would see that Jupiter has got a gravitational constant of 24.79 and Venus has got a gravitational constant of 8.87. And so this is trying to get you to think about the fact that bigger bodies exact bigger, or in this case larger, gravitational forces, but also the effect of mass that a certain body pulls towards itself is also another contributing factor. So it's trying to make you think about the effect of mass and gravitational constants in different scenarios. So let's go ahead to calculate the gravitational force for each astronaut on each planet. So first of all, I'll clear my workspace as usual. So for example, in this case, we were told an astronaut who weighs 95 kg on Venus. So I would go mass 1 equals 95 kg, and I'll go gravitational constant in Venus, so G underscore Venus is equal to in this case, what is it, 8.87, and we also have mass 2 in this case, which is 50 kg, and this astronaut is currently on Jupiter, and the gravitational constant in Jupiter is what, 24.79. So because the equation we got from the previous question is for a different planet entirely, so that equation we derived, or the model we derived using Python, is from a different planet which we weren't even given the name. So you can't apply the model of one system to a completely different or exclusive or separate system. So what the question is trying to keep you thinking of is equation 1, which is Fg equals m multiplied by g. It's, like I said in the last video, it's a theoretical equation that has been proven to be right regardless of what planet you're on. All you need to change is the gravitational constant so that you match the gravitational constant on that planet for the equation to work. And so in this case, what we're then going to do now is calculate the gravitational force the astronaut on Venus would experience. So force on Venus is equal to mass 1 multiplied by the gravitational constant in Venus. So just to give a bit of follow through with our code. I'll just label this as force experienced by astronaut on Venus. So then I can come here and say the same thing. Force experienced by astronaut on Jupiter. So I can say F Jupiter equals mass 2 in this case, multiplied by gravitational constants in Jupiter, and I can run it. And we can go to our variable explorer. So the force F underscore Jupiter is the force experienced by the astronaut that weighs 50 kg, who is currently in Jupiter, and the experience of force using the equation F equals mg, the experience of force of 1239.5 Newton, and the astronaut in Venus experiences of force, when we look for F Venus, experiences of force of just 842.65. So just for ease, what I'm going to do is print out the results so that we can have it at the bottom here, or rather actually yes, actually, so they are close together. So in the question, someone weighs 80 kg and they are on Venus. They only experience a force of 842.65 Newton. But someone who weighs 50 kg on Jupiter weighs 1,000, experiences a force of 1,239.5 Newton. And this is essentially trying to drive home the idea behind the effect of the mass and the planet you're in, or rather in this case the size of the body. So because planets vary in size, their gravitational constant would be different, and the size of a planet is in a way dictated by its weight. So like the heavier something is, the bigger it's likely to be, but that isn't always the case, because by the time you start to think about things like neutron star, all that stuff, and you get into like cosmology and planetary physics, like it gets really weird. But the idea here is that bigger things exert bigger gravitational forces on things compared to smaller things. So Jupiter is a bigger planet, and because its gravitational constant, which is an indication of how fast it's pulling something towards it, which is a value of 24.79 meter per second square. So that is how fast it's pulling something towards itself, or how fast the astronaut weighing 80 kg, weighing 50 kg is accelerating towards the center of Jupiter. But in this case, an astronaut weighing 95 kg, which is nearly twice as heavy as the person on Jupiter, is only experiencing an acceleration towards the center of Venus at a rate of 8.87 meter per second square, which is g in this case, which is the acceleration due to gravity. So Jupiter, because it's bigger, pulls things faster towards itself compared to smaller planets, and that is why you could be a lighter person on a bigger planet, but you experience a greater force of gravity than if you were an heavier person on a smaller planet. So that is what this question is trying to help you think through, or make you think through in this case. And to do it in one line, similar to the results we generated in question 6, where we made it into a single array instead of doing it separately, we can do the same thing here. We can just say masses equals, then we put that in brackets. We say we can do it in any order as long as we know what stuff means. So in this case, we can say masses is 95 and 50, and we can say gravitational constant is, in this case, 8.87 for Venus, because we put the weight of the astronaut on Venus first, so we have to maintain the same arrangement here. And then we put in the value for Jupiter, which is 24.79 in this case. Then what we can then do there is simply use the multiply function in NumPy, so we can give our array a name such as force, or you can call it anything, equals NumPy dot multiply, and in bracket we put the masses in this case, comma, the gravitational constant. So essentially we are performing equation 1, which is F equals m multiplied by g, but in this case for an array, because we've created an array of masses and an array of gravitational constants. So we can then say print force. So we can run that, and you can see here we have the values 842.65 and 1239.5 Newton, which is the same as this, the force on Jupiter and the force on Venus. So this is the end of all the solutions to the Python worksheet. I hope you enjoyed it, and I also hope you learned some stuff both from a coding perspective and also thinking through scientific problems before you then write a code that does the analysis you want it to do. Thank you very much for listening.